Hello, I am Kaushal Khanna. My topic is resource management and allocation. And this is the C code implemented to create that system programming application. And this C program simulates the process execution with memory allocation and CPU usage using threads. And the hashtag includes standard input output .h to hashtag include pthread.h. These are the headers. These are the libraries used in this code. The hashtag include standard input output.h includes a standard input output library for input output operations. Hashtag include standard library.h includes a standard library for memory allocation, process control, conversions. Hashtag include unistandard.h includes a POSIX operating system API for Unix. Hashtag include pthread.h includes a POSIX thread library for multi-threading support. And I'm defining memory size. Define memory size 1024. These are the constants and structures. Define memory underscore size 1024 defines the size of memory as 1024 bits. And type def struct defines the structure process to store process details. In PID is a process ID. In CPU underscore usage is CPU usage percentage. And int memory size is memory size required. In memory underscore block is a memory block allocated. Int is underscore allocated is allocation status 1 if allocated, 0 otherwise. 0 is free, 1 is allocated. And int memory block memory size array. The int memory block memory size is the array to represent memory blocks initialized to 0. Void initialize underscore memory function to initialize all memory blocks to 0 indicating they are free. And next is that allocating memory block memory allocation. Int allocate memory block in size a function to allocate a block of memory of a given size. Loops through the memory array to find a continuous free block of required size. Marks the found block as allocated by setting the respective indexes to 1. Returns the starting index of allocated block or -1 if allocation fails. And next is that void simulate CPU task. It, it, it is the CPU and memory task simulations. Void simulate CPU task in duration simulates CPU intensive work by performing a loop. Void simulate memory task in size in memory underscore block. It's a placeholder for memory intensive tasks. Currently empty. And next comes the void simulate underscore process. Simulate it's a process execution which simulates the process execution. Void simulate underscore process void asterisk argument in parentheses. This is the function executed by each thread to simulate process execution. It casts the argument as IRG's argument casts argument to the process pointer. Check if the process is already allocated. If so, it prints a message and simulates CPU and memory tasks. If not allocated, allocates memory, simulates CPU and memory tasks, and then frees the memory. Next comes the main function. Main function int main function is a main function of the program and calls initialize memory to initialize memory blocks and creates array of processes structure to simulate process, creates threads to simulate each process, waits for all threads to complete using pthread underscore join, waits it waits for all threads to complete using pthread underscore join, and it prints the allocation status of each process, returns 0 to indicate a successful execution. This program simulates the memory allocation and process execution using multi-threading with CPU and memory tasks for each process. So using this program, I have created an application. I have compiled this program through terminal. I have compiled the program. The GCC is the GCC hyphen object, the file name stored in that object, and the file name is the way to compile the file. When I compile the file, I get this application which is in the resource management and allocation folder. This is the application RM. The code which I have compiled is rm.c, that is stored in the object rm. So the application is created as rm. This is the application. This application which is executable, and when then I have executed this application, that is dot slash that application name. So I got the output of the application. The input data is given in the code, and will execute in output. I have output I have got from the application by giving input data in the code. The output I have got, actually I have given input. Let's go to the code. I have given input for 5 process. This is the input. Like I have, this is the process ID, process 1, 2, 3, 4, 5, and this is the CPU. This is a CPU time, and this is the memory allocated for each process, and this is the memory block size, and this is the that process which is free, determines the process is free or allocated. 0 means that memory block size is 0, means then it tells that the process is free. If the process, if the memory block size is 1, then the process is allocated. It says that process memory is allocated. Let's go to the output. When I executed the code, I have got the output for each process. Like this is the input output data, that is our process is input output data. 5 processes are input output data, and the CPU intensive task. The CPU usage of each process is calculated here, and the memory intensive task of each process is calculated here. And these are the respective the values of each process. Then I have got by by checking the CPU and memory of the process, I am able to detect the process allocation status, whether the process memory is allocated or not, whether the process memory is allocated fully or it is or the memory is free. And I have created this application by code, which I have shown you by compiling the file with command. So I get the application in the respective folder, and I can open my terminal here also, so that I can perform my I can compile the file and do output operations by opening the terminal here itself. And now I will tell some of the steps in which the application code which I have created, the basic things which we need to know that to create the code for the application. For resource management and allocation, we need to know the coding concept, basic concepts of CPU scheduling and process states and threading concepts to do this coding to make an application. Actually, we can create the we have to know the basic concepts of the threading, then only we will be able to create the application. For that, we need to understand the system basic programming, the system programming basics. First, I have implemented this code in C. I need to know the C level programming, learn at least a low level programming to gain proficiency in this C code to get better understanding of the concept. And I need to understand the OS concepts. I need to know the principles such as principles such as process threads, process memory management, and input output systems. And I need to define the certain system requirements that I need to know. The resource management. I need to know how the system will manage CPU, memory, and input output resource. And resource allocation. I need to know about the resource allocation, that I outline the policies and algorithm for resource allocation. Example like scheduling algorithms and the segmentation for memory management. Especially I need to know about the process CPU utilization and memory allocation of it. Interfaces and application programming interfaces, I need to know I need to know how the application interact with the OS and other applications, and I need to know how to design the system architecture, modular designs like how to break down the system into manageable modules like CPU scheduler, memory manager, input output manager. And I need to know about the data structures and to design the appropriate data structures for managing resources like process control blocks. Here I have assigned the memory blocks. Like those memory blocks, I need to know how to allocate the process in it. And memory tables, inter process communications decide on the process response to allocate how much amount of memory in it, memory blocks. And I need to set up the develop environment, especially to execute and compile the codes. I need to know the certain commands like gcc to gcc hyphen object name where the file stored, the file name to store the file in it and execute it, compile and execute it. And I need to know to how to I need to know to develop core components like memory implement. How I need to know uh, how to implement memory allocation techniques, manage memory access and protection, and handle the device drivers and interrupts, secure service routines, manage input output scheduling and buffering. And I need to know how to implement resource allocation policies like CPU allocation. I have developed this algorithm for distributing CPU time among the processes. And memory allocation, the implement techniques to allocate memory for the process. And process should be allocated in a memory, and the, some process is not allocated with a memory. The input output allocation needs to be known for managing input output requests and device usage, and integrating components ensure seamless interaction between CPU scheduling, memory management, input output handling components. Implement implement three-tier process of it, and implement inter-process communication mechanisms if required. And we can do the testing and debugging if required to for unit testing, test individual components to ensure they work correctly. Integration testing, test how the components work together. Stress testing, test the system under heavy load to identify bottlenecks or ensure stability. And the performance of algorithms. I, the algorithm which I have written, we can measure the performance of algorithm. We can do fine tune scheduling and allocation algorithm for performance, and we can do resource monitoring to implement the tools which we are implementing to monitor resource usage and identify inefficiencies. And finally, the code which I have done should be documented, and ensure that the code is well commented and documented. User should be able to write comprehensive guides. There should be manuals for users to develop the code, and updates, plan for updates and maintenance to handle new requirements and fix bugs. So once again, This is the code. Once again, the headers we have mentioned and the structure we have defined, and we have initialized the memory, and we allocated the memory block, and we simulated process scheduling for CPU tasks and memory tasks. We have simulated process in a given condition. Process allocated. I have printed the memory block and printed the simulating CPU intensive task, and I have called a function, then I have returned null, and I allocated the memory block. Allocated the memory block. Then the process allocated is 1, means the process is allocated me equal to 1. That means the memory block is 1, means then the process is allocated with memory, and we are printing the simulating CPU intensive task and memory intensive tasks. We have called a function for CPU and memory same, and I have given for loop to visit each process. Process allocated 0, process allocated 1 means then is allocated. Process allocated 0, then it is opposite, that is the process is free. Process memory is free. Given condition, if memory block equal to 1, then I printed the allocation status. Else, that if memory block is 1 means then I printed allocation status that the memory is allocated. Else there is also, then visit all the process and checks for the memory, checks for the process in which the memory that is free. Within main I have given the initialize the memory function, then I have given the process of 5 process and their CPU intensities and memory intensities, and memory block says with the process that is allocated or free. This is the input data, and I have given the code and the process thread. I have done threading for each process. Then I have printed the finally all process, whether that is allocated or free. Allocation status of all process finally is printed, whether the process allocated or free. Then the code has been ended. Output has been got from the input. The CPU intensive tasks, the process input data, 5 process input output data, and the process respective CPU intensive tasks and memory intensive tasks. Those CPU values of each process and memory values of each process. By CPU intensities and memory values of each process, I have calculated the check allocation status of each memory, where the allocation status of each process, whether the process memory is allocated or free. So like this I have applied in the code for 3 input datas, and I have got output for those input datas through this terminal. Those outputs are here. 3 outputs are here, and this is the code, and this is the respect output has been documented. Thank you.